Okay, so now let's talk about inverses for a second. This is actually something you would have learned in chapter 6 right when we got back. So if you didn't go through the book during those 2 weeks before spring break, this will be a little difficult for you because you haven't learned it. So an inverse function is basically 3 steps. Okay, so if I have this function right here, y equals 2x plus 4, and I want to find the inverse of it, it's kind of like the opposite, but it's really just the process of switching the x and y's, because like he says in Ingenuity, the graph of your inverse is just a reflection of the function across the line y equals x. So basically, guys, if I flip everything across that line y equals x, that means I'm just switching y and x, okay? So first thing you're going to do is literally just replace x with y in the equation. So now instead of y equals 2x plus 4, I'm going to get a marker that is spazzing on me. Hang on. You're going to get x is equal to 2y plus 4. So first thing you want to do is just switch x and y. Okay, pretty simple. Then you're going to solve for y to get it back looking like it's supposed to. So I'm going to subtract the 4. So I've got x minus 4 is now equal to 2y. Divide everything by 2. So my inverse function is going to be that 1/2 x minus 2 is now equal to y. And the last thing you want to do is just put in inverse notation, which means it's still function notation, like we have the f of x, but you're going to see this -1 on it, and that means the inverse. You'll also see that button in your calculators. So that to the -1 power looking button really means the inverse, okay? And we learned about that in matrices too. So this is our f inverse function, and it's 1/2 x minus 2, because all I did was switch x and y and then solve for y, okay? Same thing goes for your exponentials and your logs. So here, if I want to graph a log function, I could make a table, guys, but you're always going to get those weird decimal values, right? So we don't want a table full of a ton of decimals because that doesn't really do us a lot of good. So what we're going to do is use the inverse to graph, okay? Because it's pretty easy to graph an exponential. It's just a curve. So when I see this, first thing I'm going to do is put it in exponential form. So I'll start with my base here, which is 2. So that's going to be 2 to the y power is equal to x, right? That's what my marker is crazy. That is what it looks like now, just in exponential form. Then we're going to find the inverse of that. So remember, finding the inverse, we switch x and y. So that's actually 2 to the x is equal to y. So there we go. This is that inverse exponential to this one. So all I'm going to do is graph this, that 2 to the x. So all I need to know is the y-intercept, which is 1 because it hasn't shifted. And then is it a growth or decay curve? Well, it's a growth because that's a 2. So when you go to graph it, I'm not sure why there's not a graph on this. If you go to graph it, you're just going to go through 1, and then this is a growth curve, right? So there's my exponential, done. And now I'm wanting to graph the log though, right? So I'm going to use the fact that this is all just going to switch across the line y equals x, which means all the x's and y's just switch, guys. So just grab this point right here, which is your y-intercept. So my y-intercept right here is 0, 1. So the y-intercept on your log function is going to be, or not y-intercept, the x-intercept now is at 1, 0. So let me get a different color here for the log. I know my log function is going to go through the point 1, 0. And instead of approaching the x-axis now, because literally all x and y values have switched. So on our exponential, remember, we can't cross x equals 0. And so what that means on the log function is that it can't cross at y equals 0. So now my asymptote is the y-axis. So I'm literally just going to take my curve and approach it and go through there and sketch it up like this. So this is my log function. And I graphed using the inverse exponential function because it's way easier to graph an exponential and then just flip it around. Okay, so there's your log function.